That it's not a paradox, they are here. So there are intelligent civilizations out there and they are present in the solar system. It's possible. Let's think, for example, what such an intelligence might look like. Well, who knows? They could have sent nano machines to our solar system. There could be probes all over the place in the solar system, but if they're the size of an iPhone, then we'd have no way of detecting them. So it could be the technology of a sufficiently advanced alien species, a civilization, is so beyond anything we can comprehend or detect that we haven't seen it and we've been fooled into thinking that there are no advanced civilizations in the galaxy. And that's certainly entirely possible.
The silence of the universe might not be a coincidence. It could be a warning. For decades, humanity has assumed that intelligent life is out there somewhere. But what if there's a reason we haven't heard from anyone yet? Recent research suggests that the universe may be far more complex and dangerous than we ever imagined. Could civilizations be disappearing before we even get the chance to detect them? In this video, we're going to explore Brian Cox's groundbreaking new solution to the Fermi paradox that's sending shockwaves throughout the scientific community. Could we truly be the only living beings in the universe? Or is Earth just a display in some cosmic zoo? Perhaps aliens are so different from us that we can't even recognize their existence. Now, one of the eeriest possibilities is that the vast expanse of space beyond Earth is completely empty. Maybe it really is, and we simply haven't figured out the exact conditions needed for life to begin. The James Webb Space Telescope is searching for rocky planets like Earth in habitable zones where liquid water can exist. But water alone isn't enough. Scientists believe another crucial condition for life is active volcanoes that supply a planet with organic compounds. A magnetic field is also necessary to shield it from stellar winds carrying charged particles. And we can't forget the importance of a large moon, which helps generate tides and stir the organic soup. Additionally, a star system suitable for life must be far from the galactic center and regions prone to supernova explosions. Yet even these conditions might not be sufficient. I strongly suspect that the recipe for life requires hundreds of other factors. In the infinite universe, the right combination might only occur once, resulting in Earth, a truly exceptional place. Many scientists, however, dislike this idea of uniqueness, since it places enormous responsibility on us. If we destroy life on our planet, it would be an unprecedented failure. Now, there's another explanation for the Fermi paradox that doesn't suggest total loneliness. What if life exists in space, but it isn't intelligent? Now, this theory was proposed in the 1990s by economist Robin Hanson. He argued that human-level intelligence might be unique and introduced the concept of the Great Filter. Imagine life arose on only 4 of roughly 300 million rocky planets in our galaxy. Now, that's still rare, and according to Hansen, all evolutionary paths must pass through the first Great Filter over 1.5 million years. Complex cells then appear on 3 planets, while the 4th remains stuck with primitive bacteria. The survivors eventually face another Great Filter a billion years later. Multicellular life emerges on just 2 planets, and large plants and animals appear another billion years later. Earth alone passes the next Great Filter, eventually producing intelligent life. In short, this theory suggests aliens might not be little green men in spaceships, but instead simple bacteria or wild creatures on untouched planets. Projects like LOOP and instruments like the James Webb Telescope are designed to detect signs of such life. Some philosophers even claim humanity has been chosen to help the universe understand itself. But the chosen ones come as a package deal. Am I right, Lana Wachowski? This non-uniqueness opens the door to some of the most intriguing and unsettling solutions to the Fermi paradox. What if many intelligent civilizations exist, but they haven't developed the technology to explore space? To reach orbit and land on the moon, humans needed major technological advances and heavy resources. Now imagine if Earth were 2 or 3 times larger. Our best rockets wouldn't be able to escape its gravity. Many known rocky exoplanets fall into this category of massive super-Earths. On such worlds, intelligent beings might have to abandon space ambitions unless they discover anti-gravity technology. Now, that's not the only challenge. Scientists suggest life could exist under thick ice layers covering warm oceans. While this protects intelligent beings from radiation, it also traps them, making space travel nearly impossible. They would need a hybrid of a submarine, drill, and rocket to escape. Even if another civilization develops technology like ours, it could be wiped out by nuclear war, asteroid impacts, or other disasters, essentially acting as additional great filters. Alien societies might also abandon space colonization to enjoy entertainment, like streaming or virtual reality, instead of exploring. Perhaps humans will eventually make that same choice. Even the James Webb Telescope might not spot these civilizations lounging thousands of light years away. Yet, our telescopes could miss advanced civilizations already spanning multiple star systems. What if intelligent aliens exist, and we simply don't see them? Our assumptions about life evolving like it did on Earth may be misleading. Evidence of extraterrestrial life might already surround us, hidden only because of our biases. According to one of the most recent scientific assessments, our Milky Way could currently host as many as 36 alien civilizations. Some of them might even be exploring star systems relatively close to Earth and wouldn't even notice. Perhaps some highly advanced extraterrestrials have already learned everything about humans and are observing us through devices that they've placed all around the planet. Maybe that's why we can't detect them, while they can see us clearly, almost like we're living in a zoo. If humans can do this to clever animals, why couldn't other beings do the same to us? Perhaps we're just characters in their favorite cosmic show. And that's not even the darkest possibility. Our galaxy might not even be a cozy zoo at all, but rather a vast, dark forest filled with ambush predators. No civilization knows what the others might do, so each one adopts a cautious strategy, hiding in the shadows. But if any civilization dares to reveal itself, it risks being destroyed immediately by the first opponent that notices its presence. Now, this may be the most reliable way to ensure survival. The possibility of such a worst-case scenario has led some scientists to criticize the SETI project, which intentionally sends signals to distant stars. So, should we prepare for an invasion now? Or is one already underway? In the spring of 2022, the U.S. Congress held its first major discussion about potential contact with aliens in 50 years. We've seen so-called UFOs countless times, but what might extraterrestrial beings actually look like? You might still imagine little green men, right? Yet, astrobiologists argue that alien life could be entirely different, and that every corner of the universe could be teeming with it. Take Titan, Saturn's moon, for example. Its surface is locked in eternal winter, with temperatures dropping to minus 180 degrees. Now, humans, we wouldn't survive a minute in such conditions, but a silicon-based organism could possibly thrive. Silicon is abundant on Earth, forming a crucial part of the planet's crust. Like carbon, it can bond with 4 other atoms, allowing the creation of complex compounds necessary for life. On Earth, silicon bonds are too weak because of the heat, but on Titan, the extreme cold would make them stable, although the organisms would likely move and react very slowly. If a silicon-based humanoid race existed on Titan, astronauts might be disappointed if they tried to shake their leader's hand. Even linguists, like those in the movie Arrival, would have to hold up a sign for days before the aliens could read even a single word. To these slow-moving creatures, humans might seem like ultra-fast superheroes. Now, the differences don't stop there. Silicon-based life wouldn't exhale carbon dioxide like humans. Instead, they could breathe out sand. Inviting them into a cozy, clean home on Titan probably wouldn't be appealing. But how common could this type of cold-adapted life be across the universe? Silicon-based organisms could exist on far more planets than humans, possibly on billions of worlds. In our solar system alone, most planets and moons are colder than Earth. The habitable regions of the galaxy could be dominated by silicon-based life, with carbon-based life being the exception. Still, many scientists doubt silicon can form complex life, claiming even in extreme cold, it can't compete with carbon. These researchers are sometimes called carbon chauvinists, though the term hasn't affected their credibility. Now, if silicon-based life seems unlikely, consider creatures that might not even rely on chemistry at all. Take a neutron star, for instance, located about 400 light-years from Earth. Its radius is only 14 kilometers, but it holds the mass of our Sun. The matter inside is so compressed that atoms have broken down into neutrons, making carbon-based chemistry impossible. Life in a neutron star would rely on the strong nuclear force, which acts only on subatomic particles. Some scientists speculate that compressed particles could form complex structures, similar to how atoms bond on Earth. If life existed at this microscopic scale, its organisms could live millions of times faster than we do. A single greeting from us could span thousands of generations for them. In this case, we'd be the ones unable to shake a hand. Neutron-based life might also not even recognize our existence, as our electromagnetic chemistry would seem absurd to them. Their population could vastly outnumber carbon-based life. Even though neutron stars are far less common than normal stars, the Milky Way still contains hundreds of millions of them, most of which we can't see. Yet beyond frozen worlds and ultra-dense stars, Earth-like planets still exist in our galaxy. They are rare, but some astronomers believe they could host carbon-based life forms similar to humans. Of course, this might be wishful thinking. Consider life on an Earth twin. Kepler 452b, an exoplanet 1,400 light-years away, is a rocky world in its star's habitable zone. It resembles Earth in many ways and has already been called Earth 2.0. If advanced telescopes find signs of carbon-based life there, it's possible that organisms could have entirely different biochemistry, such as a different chirality, despite the familiar conditions. This property allows organic molecules to have the same composition and structure while appearing as mirror images of each other, similar to how your right and left hands match, yet they're not identical. What does this change? If researchers on Kepler 452b encountered a creature whose chirality is different from what we know, our equipment made on Earth wouldn't register it as a living organism. Molecules that are left-handed in the human body would be right-handed inside that creature, and the reverse would also be true. This means every sensor or detector built on Earth would actually fail. This concept works so well that some organisms on our own planet use opposite chirality to gain an advantage. The bacteria responsible for anthrax has a right-handed protein shell. That tiny difference allows it to slip past our immune system, which relies on left-handed detection. At the same time, it means that if a creature with this unusual body chemistry tried to eat a human, it wouldn't get proper nourishment and might even get sick. Now, this idea appeared in the Mass Effect video games, where the Turians had protein chirality opposite to that of other species. But what if, in reality, it's our Earth-based chirality that's unusual? Astronomers estimate that there may be up to 300 million Earth-like planets in the Milky Way, and many of them could still be unsuitable for humans simply because life there might develop with opposite chirality. And what if other regions of the universe are filled with beings capable of turning our understanding of life upside down? Who could potentially be living in those distant places that we currently think of as empty and lifeless? Here's the asteroid belt, a cluster of rocks left over from the early formation of stars and planets. Similar belts appear in other star systems as well. These asteroids contain many useful resources, including carbon and metals like iron. We would certainly like to use them, but some living machines might get to them first. Now let's discuss Brian Cox's thoughts on the Fermi paradox. Brian Cox, the British physicist and popular science communicator, has often addressed the question of extraterrestrial life and why, if it exists, we haven't encountered it yet. Now, Cox approaches the paradox with a mixture of scientific rigor and cautious humility, emphasizing both the immensity of the universe and the fragile conditions required for life to emerge. Now, Cox points out that the scale of the cosmos is almost incomprehensible. There are hundreds of billions of stars in our Milky Way alone, and each star could host multiple planets. Multiply that across the billions of galaxies in the observable universe, and the numbers, well, they become staggering. Statistically, it seems almost certain that life has arisen elsewhere. Yet despite these overwhelming odds, we see no evidence of other civilizations. This is the very core of the Fermi paradox, the apparent contradiction between the high probability of extraterrestrial life and the complete absence of signs of it. One key aspect Cox highlights is the enormous timescale involved. Our galaxy is over 13 billion years old, and human civilization has existed for only a few thousand years in comparison. Even if intelligent life arose elsewhere, the timing may never line up with ours. Civilizations could rise and fall millions of years before we even existed, leaving no detectable traces. Similarly, our own species might be the first to reach a level of technology capable of detecting others, or perhaps we're still too early in cosmic terms. Now, Cox often stresses that when we talk about contacting aliens, we're assuming that other civilizations are not only alive, but are technologically advanced at exactly the same time we are. Cox also addresses the question of detectability. Even if intelligent life exists, it may not be trying to communicate, and we may lack the tools to recognize it. He points out that human signals like radio waves fade quickly and become indistinguishable from background noise after a few dozen light years. In the vast emptiness of space, detecting another civilization's signals is like trying to find a single candle flickering across a continent during a storm. The universe might be filled with life, but the signs are subtle and dispersed, making them extremely difficult to observe. Advanced civilizations may also deliberately avoid broadcasting signals to avoid potential threats, an idea consistent with the dark forest hypothesis. Another point Cox emphasizes is the difference between life and intelligent life. The Fermi paradox is not just about life existing elsewhere, but about advanced civilizations capable of interstellar communication or travel. Cox notes that microbial life may be common, but intelligent, technological life may be extraordinarily rare. He draws attention to the fact that Earth's own history shows how unlikely complex intelligence is. For billions of years, life existed here only as single-celled organisms. Complex multicellular life only appeared about 600 million years ago, and intelligent, tool-using species only in the last few million years. Even on a planet with life, the emergence of a civilization capable of building telescopes, spacecraft, and radio antennas is far from guaranteed. Cox also discusses the so-called Great Filter, a concept related to the emergence of intelligent life. The Great Filter suggests that there may be one or more extremely unlikely steps in the development of advanced civilizations. For example, life may appear often, but the transition from simple cells to complex multicellular organisms could be extremely rare. Alternatively, civilizations might self-destruct soon after developing advanced technology, whether through nuclear war, environmental collapse, or uncontrolled artificial intelligence. Cox stresses that the filter could be behind us, meaning the emergence of intelligent life is extraordinarily unlikely, or ahead of us, implying potential dangers for humanity. This uncertainty adds a layer of urgency to understanding both our past and our future as a species. Cox also considers the role of probability and randomness. He argues that life may be rare not because it's impossible, but because the specific combination of physical, chemical, and environmental conditions required is extraordinarily unlikely. Factors such as a stable star, a planet with plate tectonics, a protective magnetic field, the presence of water, and the right mix of chemical elements all contribute to the emergence of life. Now, while these conditions may exist elsewhere, the exact timing and combination required for intelligent life may make Earth an exceptionally rare occurrence, at least in our observable region of the galaxy. Interestingly, Cox also discusses the psychological and philosophical dimensions of the Fermi paradox. Humans tend to assume that life must be similar to us, that intelligence must follow a predictable path, and that advanced civilizations would inevitably want to explore or colonize space. Cox warns against this anthropocentric view. Aliens, if they exist, may be so different from us that we cannot recognize their activities or even their existence. They might communicate in ways that we can't detect, live in environments we consider uninhabitable, or pursue goals entirely alien to our understanding. In his view, the absence of evidence is not evidence of absence. It may simply reflect the limitations of our perspective and our technology. Now, Cox also speculates about the possibility that advanced civilizations exist, but choose not to interfere or to reveal themselves to emerging civilizations like ours. This concept aligns with the zoo hypothesis, where Earth could be part of a cosmic experiment or observation. Cox is careful to frame this not as a proven theory, but as a logical possibility given the silence we observe. The universe might be teeming with life that we are currently incapable of detecting or even understanding, emphasizing the humility required when considering the Fermi paradox. Now, if you enjoyed this deep dive into the Fermi paradox, make sure to hit like and subscribe for more mind-blowing science content. Drop a comment below with your thoughts. Do you think we are truly alone in the universe?